Okay, class, in this lesson, we are going to learn to use the unit circle to evaluate the trigonometric functions of any angle. Okay, so let's go ahead and get started with the first example. So here we're going to use the reference triangles to evaluate the sine and cosine of a particular angle. Okay, so the question here is, what are the sine and cosine of the angle 2 pi over 3 or 2/3 pi? Okay, so the first thing we want to do is to identify where 2 pi over 3 is. Okay, if you recall from our previous lesson, 1/2 circle is pi, and so 2/3 over pi, or 2 pi over 3, should land right about here on the unit circle. Okay, now that should also equate to the fact that this is going to be 120 degrees, okay, from the initial starting point, which is right here, okay, which means that the reference angle from this line to the axis works out to be 60 degrees, okay. Now we can go ahead and drop a right angle as such. We'll make this dotted, okay. And when we do this, you see that we have a right triangle, okay. Now, because this angle is 60 degrees, we know that this angle, therefore, is 30 degrees. Okay, now in a 30, 60, 90 triangle, we know that the side opposite the 30-degree angle is going to be 1/2. And the side opposite the 60-degree angle is going to be square root of 3 over 2. Okay, now in a unit circle, we know that the x value is the cosine part of the function, and the y value here would be the sine. So therefore, the cosine let me go ahead and abbreviate this. Cosine of 2 pi over 3 works out to be -1/2, because we are in the second quadrant, and then the sine of 2 pi over 3 is square root of 3 over 2. Okay, so the key to working out this particular example or a problem like this is to recognize that this is a 30, 60, 90 triangle, and then it's also important to remember the characteristics of a 30, 60, 90 triangle, and that is that anything at the side opposite the 30 is going to be 1/2, and the side opposite the 60 is going to be square root of 3 over 2 when we're dealing with the unit circle. Okay? All right, so let's go ahead and move on to the next example. So now we're given a particular degree, and the question here is, what are the sine and cosine of -45-degree angle? Okay, so first we're going to need to identify where -45 is. And as we know, when we are talking about a negative angle, we're going to start at the initial position and we're going to go clockwise 45 degrees. So that takes us over here. Okay, so we can go ahead and draw that line, and then we can go ahead and drop the side, creating a right angle. And I'm going to go ahead and make this dotted and make sure to label that right angle. Okay, now we know that this is 45 degrees, and so this is going to be a 45, 45, 90 triangle. Okay, and if you recall from your geometry days, in a 45, 45, 90 degree triangle, the sides of the legs are going to equal square root of 2 over 2. Okay, for both legs, the x and the y value, square root of 2 over 2. And so therefore the sine of negative 45 degrees is going to be the y value, and because we are in the fourth quadrant, the y value is going to be negative, and so this is going to be negative square root of 2 over 2. And then the cosine of negative 45 degrees in the fourth quadrant will be a positive square root of 2 over 2. Okay, and so those are our answers for this example. Okay, now let's move on to a different example with a different variation. Okay, so here we are going to use the Pythagorean identity, which is sine squared theta plus cosine squared theta equals 1 to solve this next problem. Okay, so the question here is, what is the sine of theta if cosine theta is negative 3/5 and the angle with the measure theta is in the third quadrant? Okay, so let's go ahead and plug all of this information in first. So let's start with the Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1. Okay, we know, given in the problem, that cosine theta is going to be negative 3/5, so we're going to replace that with negative 3/5. So sine squared theta plus negative 3/5 squared is equal to 1. Sine squared theta plus negative 3/5 squared works out to 9/25, and that is equal to 1. Now we're going to subtract 9/25 from both sides. And we get sine squared theta is equal to 1 minus 9/25, right? Because these cancel each other out. Okay, now we have to convert 1 into 25ths, otherwise we can't subtract the fractions. So this works out to sine squared theta is equal to 25 over 25 minus 9 over 25. And sine squared theta works out to 16 over 25. Okay, now we're going to need to take the square root of both sides so that we can identify what sine theta is equal to, and this works out to 4/5. Okay, now don't get overly excited just because we have an answer, right? Because we have to make sure, especially when we're dealing with the unit circle, to know exactly what quadrant we're talking about. Now in this problem, we are to find the angle, we're trying to find the measure of theta in quadrant 3. And so we should know that all values in quadrant 3 are negative. And so the answer to sine theta should be negative here. Okay, so that is the answer to this example. Okay, so moving on to the following example. So now we're asked to find the tangent of negative 5 pi over 6. Okay, so in the previous examples we were looking for sine and cosine. Now we're talking about tangents. Okay, so before we even start this, let's just make sure we understand that the tangent of a particular angle, let's say theta, is equal to sine theta over cosine theta. And now why is that? If you recall, with tangents we're talking about the opposite side over the adjacent side. Okay, so within the unit circle, the opposite side in a right triangle will always be the sine theta, because we're talking about the unit circle, and the adjacent side will always be the cosine, and this is why tangent of theta is equal to sine of theta over cosine theta. Okay, so having said that, let's go ahead and do the next step, which is to identify where the tangent of negative 5 pi over 6 is. Okay, so negative 5 pi over 6 means that we're going to start in the initial position and we're going to go clockwise. Okay, clockwise. We're going to need to figure out where negative 5 pi over 6, and that should land us right about here. Okay, so let's go ahead and draw that line. All right, and just label the fact that this is negative 5 pi over 6. Okay, so if that's negative 5 pi over 6, that means that this angle in here is pi over 6. Okay, and pi over 6 works out to, in terms of degrees, to be 30 degrees. Okay, now if you don't know that conversion off the top of your head, okay, remember to use the following conversion, and that is, if you have a radian, okay, you're going to multiply this by 180 over pi, and when you do, this works out to 180 over 6 because the pi's cancel out, and 180 divided by 6 works out to be 30. Okay, so this is how we got 30 degrees. Now, again, we're going to create a right triangle. So I'm going to go ahead and drop this side of the triangle, and we're going to make this a right angle, and we're going to go ahead and just change this to a dotted line. Okay, so now what we have is a 30, 60, 90 degree triangle. Okay, as you know, the side opposite the 30 degrees, so if this is 30 degrees, the side opposite of that is going to be 1/2. So this side is 1/2, and then that means the adjacent side, or opposite the 60 degree angle, is going to be square root of 3 over 2. Now, since this is in the third quadrant, both of these values need to be negative. Okay, so let's go ahead and go back to this equality. Okay, so we can go ahead and say that the tangent of negative 5 pi over 6 is equivalent to the sine of negative 5 pi over 6 over the cosine of negative 5 pi over 6. Okay, now the sine of negative 5 pi over 6 is going to be the y portion of this right angle, and so that's negative 1/2. And the cosine of negative 5 pi over 6, we've already identified to be negative square root of 3 over 2. So we can go ahead and put in negative square root of 3 over 2. And then now that we have to resolve this, we have a fraction in the denominator. So we're going to multiply the top and bottom by the reciprocal. So this will be 2 over the square root of 3 times 2 over the square root of 3. Okay, now we have a negative over a negative, so those cancel each other out. So we're going to go ahead and make those positive. Okay, and when we go ahead and multiply the denominators out, both of these cancel each other out. Right, so the square root of 3 cancel each other out, the 2's cancel each other out, which means we're left with 1 over square root of 3. Okay, these 2's also cancel each other out. So this is why we have 1 over square root of 3. Now, in proper mathematics notation, you cannot have a square root sign in the denominator. So we have to convert that. Okay, so 1 over the square root of 3 can be multiplied by square root of 3 over square root of 3. And when we do, we get square root of 3 over 3. And so the tangent of negative 5 pi over 6 is square root of 3 over 3. Okay, all right, so let's go ahead and take a look at another example. So here we are asked to find the tangent of 3 pi. Okay, the tangent of 3 pi. Okay, so we already know that the tangent of 3 pi is equivalent to the sine of 3 pi over the cosine of 3 pi. Okay, so the next thing to do is identify where 3 pi is. So if we start in the initial position and we rotate counterclockwise, when we go full rotation, that takes us to 2 pi. But we needed to go to 3 pi, so we have to go another half rotation. So that takes us over here. Okay, so we're going to go ahead and draw this line here. And at this point here, this becomes 1, 0. Okay, that is the coordinate of that particular point. Okay, 1, 0. And so the tangent of 3 pi is equal to sine of 3 pi over cosine 3 pi. Sine of 3 pi is the y component of this coordinate, so it's just 0. And the cosine of 3 pi is the x component of this coordinate, and that's 1. And 0 over 1 works out to be 0. Okay, so the tangent of 3 pi is equal to 0. Okay, moving on. Here's our last example. Okay, so now we have to evaluate the reciprocal functions, reciprocal trig functions. Okay, so we're asked to evaluate the secant, cosecant, and cotangent of a 135-degree angle. Okay, now just refresh our memory. The secant function, so secant of theta is equal to the inverse cosine, so that's 1 over the cosine of theta. The cosecant of theta is the inverse of sine, so that is 1 over sine of theta. And lastly, the cotangent of theta is the inverse of the tangent function, so that's 1 over the tangent of theta. Okay, so now that we've established those relationships, let's go ahead and find out where a 135-degree angle is. Okay, so we're going to always start in the initial position, and we're going to rotate 135 degrees. Okay, so that's going to put us right about here. Okay, 135. Okay, so if this is 135 degrees, that means this has to be 45 degrees, because a half rotation is equivalent to 180 degrees. Okay, so hopefully you should be able to recognize now that this is most likely going to be a 45, 45, 90 degree triangle, which it is. So let's go ahead and create that triangle. All right, so now we have a 45, 45, 90 triangle. Okay, and we know that the sides opposite the 45, or the sides of the legs of this triangle, are square root of 2 over 2 and square root of 2 over 2. Now, remember, whenever you come up with the lengths of these sides of the triangle, we always need to make sure that we know what quadrant we're in, and because we are in quadrant 2, okay, quadrant 2, our x value is going to be negative. So we have to make sure to put the negative sign. Okay. All right, so now that we have those values, we can go ahead and calculate secant, cosecant, and cotangent of 135 degrees. So we know that the secant of theta is 1 over cosine, so that's going to be 1 over the cosine of theta, and the cosine of theta is the x value, so that's going to be negative square root of 2 over 2. Okay, that works out to, and let me go ahead and show you the math instead of just going straight to it. We're going to multiply the top and bottom by the reciprocal. So this is going to be 2 over square root of 2, and this is going to be 2 over the square root of 2. These are going to cancel each other out. Okay, don't forget the negative here. And this is going to work out to negative 2 over the square root of 2. We know that we can't have the square root sign on the bottom, so we need to multiply both of these, the top and bottom, by the square root of 2 over the square root of 2, and this works out to be negative square root of 2. Okay, sorry I ran out of room here. Let me go ahead and move these over a little bit so I can better reflect what I wrote here. Let's try this again. Okay, so as I was saying, this works out to, let me go ahead and erase this a little bit more. All right, so this works out to negative square root of 2. Okay, this square root of 2 times square root of 2 gives us 2. The 2 and the denominator and the numerator cancel each other out, so we're left with negative square root of 2. Okay, moving on to the sine function. Sine function also is 1 over the sine of theta. Sine of theta is the y part of the triangle, so that's square root of 2 over 2. This time it's positive. We don't have to go through all of this math because we did it for the secant portion, so we know this is going to end up being square root of 2. Okay, no negative this time because the sign is positive. And then the cotangent of theta is 1 over tangent. And let me go ahead and move this down so we got a little more room to work with. All right, there we go. So we know that 1 over tangent, we know that tangent is going to be sine over cosine. So sine over theta over cosine over theta. We've got to flip this around, so we need to multiply this entire fraction by the reciprocal, which is cosine of theta, divided by sine of theta. We need to do the same thing at the top, cosine of theta over the sine of theta. And the beauty of multiplying by the reciprocal is that these functions cancel each other out. So sine of theta cancel out, cosine of theta cancel out, and so now we're left with just cosine theta over sine theta. Well, what is cosine theta? Cosine theta is the x part of the triangle, and that's going to be negative square root of 2 over 2, and that's over the sine of theta. Sine of theta is the y portion of the triangle, and that is the positive square root of 2 over 2. Well, when you have a negative square root of 2 over 2 divided by square root of 2 over 2, this works out to be negative 1. Okay, so let's go ahead and finalize our answer. Secant of 135 degrees is equal to negative square root of 2. The cosecant of 135 degrees is equal to square root of 2. And lastly, the cotangent of 135 degrees is equal to negative 1. So those are our answers. Okay, hopefully that made sense. I know that it was quite a lot of information to cover, but if any of this was confusing, I would recommend that you go back to the beginning of this recording and listen to it again. Thank you.